All right. Well, for people who are joining us on this live stream, this is another in our long series of meetings about chemistry functionality for Wolfram Language. And it's been a little while since we looked at this. So let's get going here. Jason, I think that's you making background noise. Okay. So where do we want to start?
Yeah, with the input form for the molecule, it's still let's see. I've kept things rather agnostic. I could still change the full form, the evaluated form for the molecule, but I think that we've settled on something that is workable.
This is different from what we've seen before. I mean, so it's not just a picture of the molecule. It's this whole object.
Right. So it produces in the notebook. It formats as a summary box. In the future, this could.
I thought that's not what we'd agreed. But didn't we go through this like a month or two ago?
Let's see. I don't recall settling on anything. I recall that we decided we wanted to improve it, but we didn't settle on anything. What I like about Graph or Mesh Region when they format as something in a notebook is that they're fully integrated. You've got context menus or perhaps attached cells and all this stuff.
No, you don't. Do you? For something like Graph, I don't think we have that yet.
So for Graph, we don't have attached cells, but we have context menus that are very interactive with a graph. And I have the functionality that I could hook up to that. I just don't have the wherewithal to create.
This was there. I had no idea we had this.
So I mean, I can imagine how like all the buttons.
No idea that was there.
I think you've said that every time, Stephen. Every time you've seen it and played with it, you've said the exact same thing.
But maybe that's a sign that we need something more discoverable.
Right. So what it does is to change the icon, right? The mouse pointer is different in a graph object. And we will have an attached cell is the plan eventually, just as we did for meshes.
But what about, the attached cell for like image 3Ds has been there for a while. I mean, there's obviously a technology for doing that. Is that not easy to hook into?
Not super easy. But it's, and the image processing team is going to take over developing that attached cell. This one is developed, the one for meshes is wholly developed by Charles and that team.
The technology is fine. It's just that the process of actually designing it takes some time. I mean, that's kind of one of the key things.
But it's not fully top level at this point, right?
Yeah, correct. Yeah. I mean, there is, yeah.
That's the issue. It's sort of an extra issue.
I see. So it's not pure.
I mean, it's pure top level, but the front end need to detect that cell is a specific cell. So you need to.
Have you talked to Lou and John about what's actually involved in this?
I've done that before. Yes, I mean doing that is not.
What do they say?
The goal is to make it top level.
Okay,
it's like in the stack of projects that queued up over there.
No, I don't understand that because I've heard about this for other purposes about attached cells. When did you last ask them?
I mean, when I was designing, it's not a matter of implementation. I mean, I write the code on front end. It's not a problem of that. It's more for us. It's more a matter of time and designing the attached cell. Right.
Wait a minute. What is it? What is the problem? Is the problem doing the UX design for the attached cell, or is the problem hooking up the attached cell, or is the problem
It's a little bit of both, okay? Because it's non-trivial to make a good attached cell. It takes many iterations to make it really good. Your initial design is never good, but then you iterate your way to something that's pretty powerful.
All right, but so do you have any draft of an attached cell for Graph?
Yes, we do.
Maybe we should look at it sometime. Maybe we can help move it forward more quickly.
That's not the issue, Stephen. It's capacity.
Okay, but the question is, what you've said is that it's effort to design the attached cell.
But you need iterate implementation to be able to do that. It doesn't help so much to have just sort of an opinion based on nothing, so to speak.
Yeah. Nobody's going to discover this menu. I mean, I certainly didn't know.
That's why we plan to do the attached cells. Okay.
Okay, fine.
Okay, this is the only thing we had at the time.
Maybe after we've had all this discussion, I'll remember it for next time.
Right.
So basically, I don't want to focus on the formatting of the molecule until we really have the innards of it, until we have a robust object. Because I'm really the only one who's kind of working on this. So could you
try to avoid that background noise? It really would be good. Sorry, I'm just
yeah.
Okay. Now we've got heavy breathing. Michael. Okay. So back to this.
Right. So it formats as a summary box. It tells you the formula, the number of atoms. I can put in the molecular weight. If you click below the fold, it can show the SMILE string.
Okay. So,
but in general, like these molecules.
Wait. There's no colon there. There's no space there. Come on, we got to clean that up.
Yes.
Right. And what are you going to do if these are much longer?
Currently, it just if they get too long, they fold over.
What do you mean they fold over? How do they fold?
Very uglily.
Okay, so that's not going to cut it, is it? So how do we generate a more interesting molecule? If I say something like, have you hooked up? If I say control equals caffeine or something, will I be able to get something that is consistent with that? How do I get this thing here?
So I believe you're going to need to evaluate the cells at the very top of the agenda.
Okay.
And then for now, you have to get chemistry backtick.
Okay. URL saved, transferred a partial file. It says, I don't know what that means. Failed. Okay, do I need to be in a prototype build?
These will work in the prototype build. They just won't have the changes I made today.
No, but this is, I'm running this in 11.3, so that's probably...
Oh, yeah, no, it definitely will.
Okay, so it needs to be in a prototype build, correct?
Yeah, or any 12.
Well, which is better?
A non-prototype. That way you can install the Packlet and get the changes I made today as I was hastily trying to fix everything. But the way you would make a molecule out of that entity is just by feeding it.
So some bug here, which I've seen for a couple of days, about system asymptotic sum.
There's a bug report for it.
No, I know. Since we have Roger here, I wonder if he's aware of it.
Yeah, I reported it too. And it is something about, it's reported, it's known. It's something about I forget what it was, function Packlet that scrapes the information for
something. Okay.
For something.
Okay, so how do I get your molecule thing? Jason?
Sorry, I was muted. Copy those into the version into the other notebook, and then they should evaluate. And if not, then the meeting could be much shorter, I guess.
Okay. So then when I evaluate this, what am I going to get? Am I going to get this molecule, this chemical entity, and then how do I get the actual molecule out of it? Can I say a molecule of that?
Yes.
Okay. Why is this hanging? Okay. That's good. All right. So now I say molecule of this. Ta-da. Cool.
And so in that case, because we have the data in the knowledge base, it grabbed the coordinates from the molecule and the structure diagram coordinates. But normally, if you just create a molecule from a name or a SMILE string, those aren't included in the expression.
Okay. All right. So let's okay. How do I get it? Can I just enter a SMILE string? I want to enter a SMILE string. Here we go. Okay. How do I turn that into a molecule? Do I just say a molecule of that?
Exactly.
Okay. So listen, there's a design. Have we had anybody from design look at this yet?
No.
Okay. Should we get somebody from design on here right now? I mean, the first of all, this thing has to be anchored at the top. Am I making sense?
Yeah.
Don't center it in this thing. I don't know why there's so much space at the bottom here. I think you're centering it. You should just anchor it at the top.
Okay, I could set up a meeting with Jeremy.
No, but we don't need to do that. I'm going to tell you that's what you need to do here. You just anchor it at the top. Okay?
Yeah.
And yeah, you probably should set up a meeting with Jeremy. I think this width here is slightly wrong and so on. Okay? And make sure that they're the right spaces there. But now, how do I, in a smile string, just remind me how to get something more interesting? Can I have brackets and things like that in here? Is that what it is?
So brackets will create a branch. No, so they should be parentheses. And so that's a case I could come up with a better error message from doing a regex on it.
Oh, that's cool. That's really cool. Wow, this is fun.
And if you look in the chat window, I just pasted a list of 10 random, rather long smile strings that you could play with if you like.
Okay, so each one of these is going to turn into a molecule. Okay, that's cool. All right, so now what can I do with one of these molecules? So let's take this molecule here, for example.
Right. So it's evaluatable. You should be able to copy paste it and work
I know
with it.
I can do that. But what will I do with it?
Right.
So I've got a molecule. How do I find the molecular weight of this thing?
So ask it for the string value molecular mass.
Nice. Okay. So what else can I compute here?
Okay. Should the string always be a smiles? I mean, it could also be something else. But at the moment, you cannot distinguish if it's an inchy or a smile. Then, or
I mean, inputting.
Yeah.
Well, so inchy. So there's a nice regex for telling whether something is a possible smiles. Inchies are nice because they always start with inchy equals.
Okay.
Right. So
is the canonical form going to be this, or is the canonical form going to be something with entities?
This is the canonical form that that we're working with now.
But I thought we had discussed having a canonical form that involves entities here, or is that wrong?
Well, so the only issue there is that that you can't have an element entity that has a charge or that has other properties. We discussed using entity instance, but it just seemed too cumbersome to.
But it's very important that we have the right canonical form. Otherwise, comparisons are not going to work. And going forward, we don't want to have had the wrong canonical form.
Great.
But I think having something that has deeply inside entities that are also questionable if they're of the right type here, I feel wrong.
Okay.
Because again, similar to chemical element is again more a bulk object. It's not a raw atom.
Fair enough. And I mean, it's
on the other hand, it wouldn't hurt to have that as an additional information about it if we know it.
What is that?
If we know what the entity is as well, that would be useful.
Yes, right. I mean,
but it's not. It's more optional. It's not required.
Right. So, in addition to molecular mass, something that says something about elements that it contains.
So we have the atom list function where you can ask for atoms of the molecule, and you can ask for atoms that match a pattern, and then
there's a function atom list.
Mm-hmm. So atom list %11, and then the second argument can be a pattern, right? An atom pattern. So it could be just the string capital O is the second argument.
Yeah, okay, but there should be a way to get this out as entities.
Right. So the second argument can be a list also, where pattern goes to string, and the string right now I have goes to indices or formal charges or something.
Okay, but what about entities?
Right. So it could be entities.
That didn't work.
Okay.
It's a blank error formal charges.
It should work. Or just try capital O there, but blank should work.
I don't understand that. What did it just do?
Okay.
No, that's not just showing me O. Right. And by the way, where are the, I mean, if these things are supposed to have annotation beyond just the atom type of some kind of charge information, where is it?
Right. So it would, okay, so those inputs should work, and I'm sorry that they don't at the moment, but that's the syntax that would work. And so anything else in an atom besides the atomic symbol is a list of rules. So atom O, formal charge goes to 1, mass number goes to 14.
Okay. So what is this doing here? So chiral center is 8. Okay. So then indexing into here. So I could have named these things and had this be an association instead of a 5. There would be a name of an atom here, right?
Right. So you could have listed the first, the atoms could be a name, goes to...
Yeah, right. So then I would refer to them. I mean, the fact that these are indexed by numbers is purely because this happens to be a list with numerical indices, right?
Right.
Okay. So then I could take, I see, so I could say molecule plot %11. That is a very ugly object. I mean, it's way too big, right? So you need the right heuristic to decide the size.
Yes.
Maybe Charles can comment on that for what we've done with graphs. I mean, fundamentally, this should be, you should try to default to have a font size that's about the standard font size for these, if there was a font, have the font size be about the standard font size, unless it gets too big, in which case you're going to have to go smaller with these things, right? Am I making sense?
Yes.
So never get bigger by default than the standard font size would be. Make sense?
Yes. So I had a heuristic, but it was doing very poorly. So I removed it for now.
So that's the heuristic that you need. Is you need something where the size of the font would be about the standard font size. Make sense?
Yes.
And presumably image size will work here, correct?
Yes.
Okay, but the question for this is, do we really want these things to scale up? Do we want those fonts to scale up like that? I doubt that we want that. Maybe we do.
So that's an area where I am a little bit out of my element. When I draw these things, I have to, so if you see the O where the lines come into the O, but they stop, what I do is I estimate the size that font is.
Okay, so Charles, what can you say about that?
Well, for graph, we use more internal dynamic label and such. I can show him how we do that for graph. So we control the distance. I mean, the front end handle the distance at the right position. So.
Okay. Sounds like the right thing to do here. I mean, these look pretty decent, though. Okay, what about if I want to do 3D? Can I do molecule plot 3D here?
Yeah. And when you do that, it's going to generate the coordinates on the fly for the model.
Wow, that's very space age. I mean, that's very impressive. Why is there so much space around the molecule in this image?
So in chemical data, we make, or on alpha, we say shrink wrap method goes to shrink wrap goes to true. But for this, I have taken so far, I add very few options to the resulting graphics 3D. But
I think we should not use shrink wrap. The experience when you touch it is too unpleasant.
Yeah, I tend to agree.
But is this one, this looks bigger even than its spherical region. Do you see what I'm saying? There's something wrong here. Right?
It's just the graphics. There's nothing but Jason does special.
Yeah, but Stephen is right. There could be, who knows if someone put some padding in there.
Yeah, something is wrong.
You just call the regular molecular plot 3D. So it's more a revision of molecule plot 3D.
Right. So there is a molecule plot 3D in the layout that was when chemical data was introduced, and what I've got is basically rewritten it, but using some of the.
Okay, I'm telling you, there's something wrong here. Okay, so I don't know what it is, but there's something wrong with the.
It could be the manually specified viewpoint, maybe.
But you already said this. Remember, a couple of weeks ago we went to anatomy data 3D. And it's just a set of graphics primitives.
Okay, well, so there's something wrong then. So this is an issue for who? For you, Sue, or for Brett?
If then you should.
Yeah. Okay.
User have been working on updating the graphic rendering and such as we use for polyhedron too. So it's possible that there is some side effect it's working on. So.
Well, so if I take this and I copy it into an older version, that should do the right thing, right? Still got that problem. Let me ask if somebody can find you, Sue.
So let's see. So another thing that you can do with molecule plot is the second argument is the highlights, things that you want to highlight.
Okay. By the way, we have a question on the live stream asking, would arrow keys rotate around the X and Z axes, X or Z axes? We don't really have a way to do structured rotation. We really only have free, is that something chemistry people care about, to be able to do rotation around specific axes?
Well, so one of the popular programs that people use to look at these is called Avogadro, and they've got this really neat thing where you right-click and you move, and it changes the center of rotation to where you clicked, and there are modifiers like shift or whatnot to change the action of rotation, whether it's around a fixed axis or whatnot. I don't know all the details.
And that's fairly common with a number of the molecular modeling packages, that sort of capability.
But is that what people want, is that they lock to a particular atom and rotate around that? Or is there some reason why one cares about specifically X and Z rotation?
Sometimes about X and Z, yes. Z being the canonical vertical axis, as it were. You basically want to spin it like a top, but slowly so you can see what's going on. Fixing the rotation around a specific atom is something that would be very useful. You're interested in the atom for some reason. It's part of an active site in a molecule or something like that, or it's the part that's binding to the active site, or it's a reaction center. So
we haven't had any of those kinds of issues for 3D graphics. I wonder what... Roger, can you comment on that? I mean, we haven't really had that issue for our traditional 3D graphics.
We had prototypes. We had prototypes of all of that, but it's what you have there is basically dragging on a sphere, so you can rotate in any possible direction. Is the default. There's a slightly different one for Plot 3D. It uses a different rotation controller to maintain.
Yes, I remember that. Right, to maintain the vertical, right? Right. But so we already have experience with different rotation controllers, but this thing here right now, molecule plot, is generating, like graph plot, it is not generating a special molecule thing. It is simply generating graphics. Correct, but presumably, Plot 3D is also just generating graphics 3D. So it must have some special option to specify the rotation controller.
It does, yeah.
Okay. So that's something we could do again here, if we could figure out the appropriate rotation controller.
Yeah, but it sort of has to be kind of a joint project with you two and so on.
Yeah, I know. Yeah, also on the live stream, Michael Hale is pointing out that, there are things where you start spinning it and it keeps on spinning. Yeah, we considered that years ago for our 3D graphics, and we never implemented that.
So let's see. So something interesting you could do if you go up to the 2D plot where you say molecule plot %11 and give it a second argument, just the word bond Sorry, as a head. So bond will specify an unspecified type of bond. 2 arguments. First argument is a blank. Second argument is a capital O. Right. And so if you change that bond to be double bond, then it should only highlight just the one bond.
Okay. That's cool. So this is different semantics from what we do for highlighting for plots, for example.
Well, we don't have highlighting for, I mean, we have highlight graph and we have highlight image, which are highlighting functions.
And in those, the highlights are internal to the expression, right? I mean, it's the, or maybe, no, you can, like, so you can wrap your vertices in wrappers to make them highlighted, but.
Yeah, exactly.
Hey, did Yutsu just join us?
Yes, I'm here.
And you're looking at the screen, yeah? Yes.
Yeah.
So we have this graphics 3D object, and we want to know why the thing has so much empty space around it. It seems to be much bigger than the enclosing sphere. Do you have any thoughts about that?
Yes, because of the bounding box. It has some. If you visualize the bounding box, you will see. Yeah.
Okay, so that's crazy, in my opinion.
We have an option called shrink wrapped method.
That's different, but I mean, so hold on. What we want is something which has the sphere but not the cuboid. In other words, it leaves space for the sphere but does not leave space for the cuboid.
So you want a smaller bounding?
Well, in other words, there's no reason to have, if you're not showing the box, I don't see a reason to leave space for the box. There's a reason to leave space for the surrounding sphere, but not for the corners of the box. Do you get what I'm saying? In other words, when boxed is false, I don't understand why it leaves extra space for the box.
Because it doesn't compute more precisely than bounding box.
That this is a very compact molecule, and if you take something that's like a hydrocarbon, a long chain, it's like looking at a rod, and what's appropriate then when you've got very different.
Let's look at that in a second, but hold on a second. I'm trying to understand from Yutsu. The statement Roger made is we're not computing the bounding sphere, but that can't be correct.
Yeah, right. Currently, if
so, what it's doing here, it looks to me, it's computing the bounding sphere for the bounding box, not the bounding sphere for the material, for the
content.
Right, which is a harder problem. Okay, in this case, for this domain, it's not that hard. In fact, we have it. Bounding region can give you that very efficiently.
For this,
yeah. For if you just have a set of points, which you have here.
Somebody's sending me something on chat. What is this? Oh. You're sending me a long hydrocarbon here. Why does it curl itself up like that? Why is it not just straight? Is that physically correct? Jason?
Sorry, I forgot that I was muted there. Let's see. So that would be... Yeah, so that would be correct. You expect a molecule like that to be floppy, is what we would describe it.
Well, I know that, but well, what the heck just happened there? Why did it suddenly get so small?
Well, so that one's got a very rectangular box. Like one of the dimensions is much different than the others, and so I think so. It does. I mean,
okay. So the basic problem here is an algorithmic problem that Yutsu doesn't know what the genuine sphere around the contents are. Is that correct, Yutsu?
Actually, we can compute that. It's just the cost is too expensive.
But you don't have to do it once and for all, right? You only have to do it once. You have to know where the center of the sphere is.
No, you have to do it even one gesture, one rotation. You have to compute it because the viewpoint changes. Everything changes.
I don't understand that. You have a physical sphere that, given the coordinates here, there is a center and there's a sphere. Why do you need to recompute that if you change the viewpoint? It's in 3D space. The sphere is in 3D space.
Yeah, just like you visualized that the box, that's XYZ range. But there's some corners there. If not visualized, it's empty. And if the viewpoint is different, the empty space will be different. So which means...
No, I understand, but we're saying we don't want the box. We're saying consider only the content, work out the physical bounding sphere around the content, given a certain view center. Or even, is that the problem? That you're looking at a particular center, and that defines the center of the sphere, right?
Yeah.
Roger, help me out here.
You're right, Stephen. If one could compute it once and for all, like in this set, it's a set of points. It's very cheap to compute the sort of minimum volume bounding sphere, but we don't have that right now. So it would be an extension to what we do. I'm pretty sure we do not have that.
Okay, so fine. So this would be an extension of Graphics 3D to give it the bounding sphere. So this is like spherical region, but it's a more sophisticated version of spherical region. Like, for example, it could be spherical region.
And I think spherical region actually uses the bounding box, is what you're seeing. Do you know what I'm saying?
Yeah, I know.
So there's just 8 points, okay? But so this one will have, in general, thousands of points.
I understand that. But what I'm saying is, imagine that a possible setting for spherical region was the center of the sphere and its radius.
Right. But in general, if you're going to do that for all of 3D graphics, it's a longer project, because then you need to sort of, how do you reduce everything to the point case? And you can't reduce everything.
I realize that. But what I'm saying is Jutsu could support a thing in spherical region, which is, an
explicit sphere.
Yeah, center. Yes, right. In fact, it should just be a sphere object. It should be spherical region, arrow, sphere of, center, comma, radius.
And then this molecule plot could actually do that computation. Yeah, it's just points.
Right.
And it can actually call bounding region, which has fast code for that.
Does that make sense, Jason?
Yes.
Okay, that's what I would suggest. Jutsu, does that make sense to you?
Yeah, I can make a method to visualize only the sphere region instead of bounding box region.
No, but remember, there's a spherical region arrow true or false option right now for Graphics 3D.
Right.
Okay, so what with... Yeah, go ahead.
But that sphere region, like Roger said, it's based on the bounding box.
I know. I'm saying instead you do this. You say spherical region arrow sphere of x0, y0, z0, right?
Okay.
Radius, right? So you make the explicit sphere, which represents, what's that?
So, do you understand? Right now, spherical region goes to true. It uses the bounding box and then computes the bounding sphere from that. This would say, take the sphere I'm giving you.
Right. Even if it's completely wrong. That's just whatever, you could specify that. That is literally specifying the sphere. It's specifying, as far as the rotation controller is concerned, this is the only thing in the image. You get what I'm saying? You too?
I don't have a question. We using plot range to provide the range to visualize. Why don't we just provide the sphere syntax to plot range?
Well, that's an interesting idea as well. I think that's a more complicated thing, because that would be doing the equivalent. So you could equally well say, why not give a region specification to plot range? It's an interesting idea. Roger, how do we? But usually we have a region function, right?
Yeah, but that's just for this functions. Graphics is a much more primitive level. As graphics better be fast, or And
I think what we should do initially is to support this as an experimental thing. If I think you should bring up the idea of making plot range have this as a right-hand side, but I think initially let's just do this.
And if it's plot range, it should really be ball, because you want.
Yes, I understand. You want the interior of the ball,
right?
Okay. So, you two, does this make sense? So for now, this would simply be a private piece of communication that we might not even document for spherical region that will be used in the molecule plot 3D functionality.
I will make an experiment thing for that. Yeah.
Great. Okay, question for Jason now. You two, why don't you hang around for a little while longer? Question for Jason. How did it determine how to curl this up?
Right. So the method for generating the coordinates is fairly neat. It's so there's some randomness involved in it. It creates a bounds distance matrix. So for every atom that is bonded, for every bonded pair, every carbon-carbon bond, we know that carbon-carbon bonds tend to be such distance apart. So the matrix element for that is bounded pretty tightly.
Okay, so let me ask a question. So is there a random seeding function for molecule plot 3D?
So the
seeding option?
There is a random seeding option, not for molecule plot 3D, for molecule or for embed molecule.
What is embed molecule?
So it's a function that would take a molecule that doesn't have coordinates in its expression, and it puts the coordinates in the expression.
So if I say random seeding here.
So here you would want to say molecule embedding goes to, random seeding goes to that.
By the way, why am I seeing this must be a bug in the prototype build. I'm seeing a bad cursor. Okay, well, let's get to that in a minute then. Okay, but what you're basically saying, this is an attempt to make a physical simulation of this.
Right. So
for example, if I take the thing I was doing before where I had this branched hydrocarbon, you're basically saying if I do that with a branched hydrocarbon, I can say molecule plot 3D of line 9, right? And it's going to show me. This is pretty neat.
Let's see, the algorithm for generating these coordinates is I think really cool. And then we've got it generates random coordinates that fulfill the bound matrix, and then it tries to do a little bit of cleanup so that things that are supposed to be planar are planar. And then we've got additional cleanup capabilities. We can apply a force field and find the local minimum under that force field.
Where does the force field come from? Is it a Van der Waals force field or something else?
I think Bob is so it's called the Merck molecular force field, and it was developed by Bob and coworkers.
Primarily Tom Hallegren. He deigned to include me as an author on one of the 6 papers because one of the referees rejected it unless I was included. But anyway, that's another story. It's a Hooke's law type spring model for bond stretching and angle bending. It's got a torsional term for twisting around single bonds. It's got Van der Waals repulsions or attractions if they get close enough for non-bonded distances. It has electrostatics in it.
Okay, so it's basically decent physics.
It is. It's what is generally accepted in the field these days.
So how does it do relative to X-ray crystallography for something which, for actual molecular atomic positions?
It does fairly well. It was actually calibrated against high-level molecular orbital calculations.
Okay, cool. Do we get to move these molecules? Do we get to have any mechanism for having these molecules move?
Move in what way? Twist around bonds and things like that?
Well, move as they would in a heat bath.
That would be molecular dynamics. And Jason, we don't have anything for that hooked up, do we?
We don't have any dynamics at the moment. That is definitely one of the things that I'd like to do in the next steps after first release.
Okay, but so just to understand what we would think would happen. So the physics you just described sounds like it could perfectly well have dynamic, if you've got a Hooke's law and things like that in there, there is presumably a Lagrangian and all that kind of thing. You could just compute what happens.
Yes, definitely.
And is it realistic to do that?
Chemists do it all the time.
But so what would the function look like?
It would essentially be doing something like simulated annealing for optimization, but keeping track of the itinerary and then replay the itinerary.
Yeah, but what would it look like at the top level? Is it like an animated plot?
Yes, it would be a list animate, something like that.
Well, and underlying that would be like a run dynamics function or something, right? Where you give it an initial condition, and then it generates some kind of object that returns the snapshots along with
molecular dynamics, not to be confused with dynamic in the language.
Right.
Right, but what you're saying is you have to have an initial configuration that is, okay, so there's two different things. One is random heat bath with the thing just wiggling around, which presumably, it wiggles at a particular temperature. This molecule will wiggle around.
Exactly. Right. There's a temperature associated with that.
Okay, so that's one thing. The other thing is you've distorted the molecule, and now you want to see what happens when you kind of let it snap back, so to speak. Is that right?
Yes. Typically, what they do is they will supply random forces on all the atoms to initiate the dynamics, so that it moves. Otherwise, it's at a potential minimum and it won't do anything.
No, I understand, but you could also do that from a heat bath, right?
Yes. Yeah.
But then it will keep moving. But what I'm trying to understand is if I pull one of the arms of this thing out, right? If I pull it too hard, it's going to break. Really?
Really? Yes. With a molecular orbital calculation, it would say you dissociated the bond, but with the MMFF model, it won't. It'll pull back.
Okay. But so in other words, what would you be? So you will be saying, to specify the initial condition, you would be saying take a particular atom and move it to such and such a position with all the atoms kind of trailing from that. Is that right? Or what would you do? You
could do that, or you could just plain put it in a bath of water molecules so that they're all bouncing around and jiggling around together and observe what it does over time. Does the conformation change?
But that's basically a heat bath, right?
Yes, and that's what is usually done. I have not seen applications where somebody stretches something and then lets it go, except for maybe grins.
What are grins?
Just to see what happens for fun.
Oh, I see.
So
I thought I was learning some technical thing like smiles.
No. The vernacular.
Okay. But so fundamentally, it's going to be some kind of animated molecule plot 3D where you give it a temperature, basically. Is that right?
Yes, and sometimes what people do, they will heat it up and then have a cooling regime, a cooling regimen.
Like annealing of some kind.
Yes, like annealing to bring it back down to see what happens. This is often done in the context of binding to a molecule. They also use, Jason, what's the thermodynamic cycle that they use for these things?
So like the Carnot cycle? Or
No, not Carnot. The free energy perturbation, to try to understand binding energies of ligands in receptors or enzymes.
You caught me out there, Bob.
Okay. All right. So listen, I have a question for you two here. Okay. As I move this thing around, there's this moment here. Do you see what happens there? It jiggled. See, as I'm moving it continuously, but it is not the molecule. I'm moving the controller continuously. Is you two with us?
I think I saw what you were mentioning. You've stopped moving it, right?
Yeah, I stopped moving it now. But did you two leave the meeting? Looks like you did. Okay, well, that's another thing to be reported to him, because there's something wrong with the rotation controller here. In other words, a continuous motion is not leading to continuous change in the molecular orientation. I don't know why. Probably because something is auto-computing some new view center or some such other thing. Is that possible? Is the view center fixed? Anybody know here? Roger, do you know?
Remember right now. Do you mean the snap to thing, or when you let go of the mouse, or do you mean when you move the mouse?
Let's see whether you two can rejoin us. Okay, let's keep going here. Okay, named atoms. Oh boy, this is something where you're doing a partial naming, but you could do a full association here with everything having a name. Is that correct?
Right. And it would evaluate to being the canonical form where they're all atom objects with the names on the inside. Just because I need a canonical form that I can,
Okay, fine. And now we decided that we don't want braces inside each of these things. Is that correct?
Yes. Mainly because there wouldn't be any other arguments or any.
Yeah. Okay.
We're not handling 3-center bonds at the moment.
Well, wait a second. What is a 3-centered bond?
Something very exotic that tends to only happen with boron. Stop me if I'm saying something wrong there.
Ions also are viewed that way sometimes, but it's kind of like, benzene having a resonance structure, a hybrid structure. Are the bonds localized or not, and that sort of stuff. And with carbocations, a carbon atom with a positive charge next to a double bond, it tends to share the electrons of that double bond, and it can be modeled and seems to behave as though there is a bond shared among 3 atoms.
I see. But so wait a minute. In the case of a benzene ring, like that guy, right? What are we doing with it? Is that okay? This is a naive question, but these bonds, they have this weird, is it a single bond? Is it a double bond thing? How is that right? Isn't that right? Or is that our aromatic bond thing? Yeah.
Those are what the aromatic bonds represent.
And we have functionality to swap it into we call it the kekulized form, where you have
fine,
double.
Fine. Okay. Did Yusu rejoin us? Yeah, it looks like he did.
Yeah, yes, I'm here.
Okay, so I'm complaining about the fact that this thing, when I move it, it isn't doing it now, this thing did not move continuously as I moved the mouse. And I'm suspecting that it's snapping to some that something is happening with perhaps the view center or some such other thing. Yeah, you see there, I think it did it again. Yeah, what the heck is going on there? It's moving it continuously, and yet its rotation axis is changing. Can you comment on that? Do you know what it's doing? I mean, as I understand it, maybe I need to put the, maybe it will be clearer what's going on if I put the box around it. Well, it looks, and then it jumps. Why does it jump? It jumps because it is shrink wrapping to the size of the cell, correct?
Yeah.
Okay. But otherwise it should be, no, what the heck did it just do there? Again, you can't tell because I think I'm moving the mouse continuously, but I think this rotation is not happening continuously. Should it be?
It should running very continuously, but there might be some bugs there.
Right, but the way it looks is it's snapping to change, for example, a view center. Where is the view center? Is it the center of the bounding box? Or
center of the bounding box.
Okay. Well, all right. I don't know how we debug this, but I think there's something slightly wrong. Okay, that's fine. All right, let's keep going. You don't immediately know what's happening.
No, the view center shouldn't be changing, but it's possibly can be a bug there.
Okay. All right. Thanks. Yeah, that's what we want to know. Thanks a lot. Okay. We're talking about what on earth is this? Okay, so this is a whole bunch of. Okay, so this is include hydrogens. What happens if I say include hydrogens to false on the molecule plot?
So for molecule plot, you could give it show hydrogens goes to false.
Why on earth do we? What's the difference in include hydrogens and show hydrogens? We can't have both.
So
why would we have two different?
Well, okay, here you're just saying whether or not they're visible. In the other case, you're creating a molecule and you want to know, do you want to create it with the hydrogens explicitly present in the data structure or not explicitly present in the data structure? Molecular modelers often work with molecules without the hydrogens explicitly present.
But why not have the same option? Include hydrogens here for the molecule plot 3D as in the molecule.
That would be fine. I mean, that would be fine. Yeah.
I think not. I think they do two different things. One is for actually generating something, creating something. And here we're just controlling visibility. it's like frame true or frame false.
Okay, but so could we then have a show hydrogens in the molecule as well, where it generates the hydrogens but does not show them?
And it gets carried along and used for everything downstream until you change it or override it, right?
I think so. That would be the idea, yeah.
So I was talking with Michael about whether molecule itself should take options for molecule plot, or whether it should be in a method option or something like that. So when you create a molecule, you could control the way that it formats.
I don't see why you shouldn't do that. Does Michael object to that?
It seems strange to me. It is not an inherent thing of the thing. It's something that you later do.
But it's an advisory thing. It's like a graph where, if I'm not mistaken, Charles could perhaps answer this. Can't you give advisory information on the embedding, which is not relevant to the graph itself, right? When you specify a graph. Charles?
By advisory information, you mean coordinate or such a thing?
Yes.
Yeah, there's a graph layout option gets included.
Yes.
Right, so that seems analogous to this, doesn't it?
Right, but I mean, but I still see them as being two separate issues, right? So when you create the two molecules there in the include hydrogens section, one of them has a much higher byte count than the other, right? One of them has if you did length of the first.
Yeah, I understand that. I understand. We're not saying that show hydrogens and include hydrogens should be the same. I'm simply saying I don't see a problem with including in molecule things which are relevant to the rendering of molecule, just like graph has things that are relevant to the rendering of the graph, because it is, even though they're not relevant to the structure of the graph. See what I'm saying?
Right. So implementation wise, do you wrap them all up into one, like a plot options goes to, and then a list of options?
I don't know. I don't think so. But Charles, Michael is objecting to the fact that it is not an intrinsic attribute of the molecule itself, things about how it is displayed in molecule plot 3D, which is of course correct. But I'm making the point that it has been convenient in graph to give things which are not intrinsic properties of the graph, but are relevant to its display right there in the graph object from the beginning.
It leads also further down to the question like equality.
Yes, that is an interesting question. I mean, what do you do with that for graphs?
But when you say equality, I mean, this is an object, so equality is relative to what you want to compare, right? So
is equality relative to mathematical content, or is equality relative to appearance?
Exactly, and that brings us to the same problem of even when you attach property to your object, right? So the property change the object by itself. So, that's why we introduce custom function. Pardon?
Like something that's called molecule, not kind of molecule appearance, I feel like it is the abstract object. So it does not change its identity through such things, in my opinion.
I think you should have, visualization properties there as well.
In the molecule.
Yeah, because, and that's what, for graph, a pure graph, it doesn't have to display at all. It wouldn't have any embeddings. It wouldn't have anything. We do all that extra work. And we do that to sort of get to networks and get to another set of very useful things. I think molecule plot and so on will also use to communicate things. So if you want to highlight things, you want to emphasize things, being able to control that is sort of important, I think.
Yes, and saving it in the molecule or with the molecule, it would be very useful. Chemists would really like that.
Exactly.
Yeah.
Okay, fine. So I think Michael is getting somewhat overruled here.
Okay.
Well, I mean, so if you're saving stuff in a molecule, like kind of what we'll call not necessarily extraneous, but visualization stuff, then you have to ask the question, when you delete an atom, when you modify it through all the different modification functions, what
do you do for graph
along with it?
Yeah, I understand. What do you do for graph about that?
You have to take care of it. That's why you have the framework of property, and it gets complicated, and you have to implement it for every single operation and every single change on your object.
Yeah, it's not free.
So free.
Right. Well, so for the time being, we could simply blow it away. If you change the molecule, you blow away the embedding information.
That's what I do right now with meta information. So you can store whatever meta information you want in a molecule expression, but if you delete an atom or something, I'm going to throw it all away.
So the same chemical Q, is that a function that? Oh, I see. We're going to talk about functions in a minute.
Right. It's like
where is the chemical Q? It doesn't seem to be here. Where is it?
It must not be there, but
fine. But it's supposed to be there.
Right. It's like isomorphic graph Q, but it's
I understand.
Considers properties. Yeah.
What is a same chemical? So a same chemical, if you have different embeddings, let's imagine that you had a thing where you gave the atomic positions and they were different.
Like I would expect most chemists to say that they are the same chemical at that point.
Even in the limit of proteins with different foldings.
Certainly with proteins, if they fold differently, they'll have different properties and be considered to be different.
But then the same chemical Q, are they same chemical Q or not?
As a molecular modeler, if I wanted to, I would distinguish the sameness based on just the topology of the atoms and the bonds and the formal charges versus the 3D geometry. I'd want to be able to test those two things separately. And
different notions of equality. That makes sense to
me.
Yeah, right. So, but does same chemical Q support both notions of equality?
So it should have a same test option, right?
Well, the same test, or it could just have a second argument. But if you're comparing two molecules and they're like numerical round-off errors of where the atoms are placed, how is it going to know what the bucket of identical molecules is?
So right now, it doesn't look at the coordinates at all.
No, I understand. But were you to do something which did look at the coordinates, how would you deal with precision issues?
And rotations. So if you took the same molecule and you rotated it, I would still want them to be considered same.
You mean rigid rotation of the whole molecule?
Right. Exactly.
Yes.
So then, I mean, you would compare the distance matrix of it, or something like that.
Or you put it, you align it with the principal moments of inertia or something.
Yes, right. That as well. And of course, would have to be.
There could be degeneracy in the principal moments of inertia.
Yes, there was certainly that, and then whether or not even if it was just for
that finer grained notion of equality, when we look at the embedding as well, the folding and so on, then clearly the topological things are very quick negative criteria. You know what I'm saying?
Yeah.
If they're not topologically equal, they're certainly not going to be sort of whatever that other equal is called.
Mm-hmm. Right. And so right now with same chemical Q calls isomorphic graph Q first. And if that says no, then it doesn't even look at the names of the atoms and everything.
Okay, fine. Actually, we have a question on the live stream about it. Can you read out, and it was also something I was wondering about, how do you read out the positions of all these atoms?
So ask it for its atom coordinates property.
Of number 32 here. So, okay, so if I say...
And you can give that a target units option to say picometers or something else.
And we're defaulting to angstroms because the SI people ultimately failed.
That's what chemists have always used.
We like our bond lengths to be about 1.
Yeah, unless you're what is it, a quantum mechanic chemist, and then you talk in Bohrs.
Okay. So what is I don't understand what this is. So this is, I see. This is the three-dimensional. These are all. So if I said,
you could do list plot 3D.
List plot 3D.
Or list point plot 3D.
Yeah, right. List point plot 3D of %36. Ta-da. Okay, great. Okay, very nice.
And so that's another spot where you should be able to say include hydrogens goes to true or false when you ask for that property. And it should give you a smaller, I say this hoping that I've hooked that up. But
so this would be include hydrogens to false, right?
Yeah.
If I say include hydrogens to false, then this thing will be less fluffy, but it isn't. Something went wrong here because I still got 107.
Right. Yeah. So
There's a mistake there.
Yeah.
Yep. Okay. All right. This is a hard to understand stereochemistry story.
I mean, that's how every undergraduate chemistry student feels as well. But okay, so the way that we were taught chemistry, stereochemistry in school is with very small molecules, where you just have 4 different substituents on one carbon, and we make the little models in our hand to show that they can be have 2 different configurations that are mirror opposites of each other. Mm-hmm. And this was so we support a simplified input. A user can say stereotype goes to tetrahedral, chiral center is 1, and direction is R, in which case we have to go through and compute all the other stuff. And it makes it a lot.
What does R mean? Oh, that means that's some kind of right-handed coordinate system thing?
No, it is a designation R or S, whether it is right-handed or left-handed, as it were, following a particular recipe prescribed by 3 chemists back in the 1950s. And that is related to the 3D geometry and the connection of the atoms.
Is there a fuller name for R and for S?
No. Well, okay, they stand for rectus and sinister.
Okay, that's kind of bizarre, as opposed to dexter and sinister.
Dextro and levo. There's also DNL, which has a long history as well, but that has more to do with the optical rotation of polarized light.
So essentially, the 3 chemists, Kahn, Ingold, Prelog, they came up with these rules of assigning a priority to all the atoms in a molecule. And when you look at the stereochemistry and you order the atoms in an increasing order of priority, do they show up in clockwise or counterclockwise? And that tells you whether it's R or S. But in order to do that calculation, you have to look at the whole molecule and compute the priorities.
But so you are able to do that here, is that correct? So if somebody says direction arrow R, you can correctly do that and fill the rest of this in.
And it takes a lot longer. So what you're seeing right there, the big list of associations, that's defines the stereochemistry locally rather than globally, and so that's very fast.
That's interesting. Okay, fine. But so this is the canonical form. You turn the global thing into local things,
right?
Yes.
Okay.
Yes.
So here, I wish I had a better name for those, but I have 2 different libraries that can generate coordinates. But I queried their authors.
Just make it a method option.
Okay.
I would say method goes to, and then this is part of the method option structure.
Okay.
And these are incredibly ugly names.
They are. I even asked. I'm on a mailing list with the authors of both of those, and I asked, could you tell me like what the method, describe the method so that I can come up with a name?
And what did they say?
One said you could call it the RD kit method, and they gave me a link to a published paper.
Can't we just name it after the people somehow?
Yeah, I can look into that. Yeah. I
mean, these are really bizarre. Unless they're very well known in the industry, I think they're really bizarre.
They're definitely not. The chord gen actually produces a nicer plot in a lot of cases, but it can be very slow, so it's not the default.
Well, then maybe we should have a performance goal.
Okay.
Speed or quality. That seems like a reasonable thing to do.
Yeah.
Let's do that, and it can switch between those 2 methods.
Yeah. Okay. I've got. I made a note there, and I have it set to so that you could use a graph embedding method, but they're not always ideal.
But the graph embedding will have no physics.
Well, the spring embedding. I mean, they
had some physics.
Well, sort of. Yeah. Jason, I was actually going to try gravity embedding on this one, but I didn't have time.
I believe that's still in the prototype.
No, I think.
Okay, but listen,
Charles.
I don't think we want a whole option to specify this. I think this is some kind of method, arrow. I mean, if I'm not mistaken, we could have something method, arrow, something like, I guess you can say structure diagram layout, arrow, and then I guess, what is the name for these things? These are graph embedding methods, but what do we call those in the graph system?
So graph layout methods.
Yeah, those are the vertex component of the graph layout.
No, I understand that, but I'm asking in the options to graph, what do we call the option whose right-hand side is spring embedding? Is it graph layout?
It's graph layout, or it's
actually a vertex layout. So you have the graph layout, which is the whole general process, and then you have the vertex layout for placement for the vertices.
And is that what these are? Is vertex layouts?
Yes.
So it's not correct, is it, to say, I mean, shouldn't it be then vertex layout? Or is that not correct?
I mean, doesn't it sound a little funny for a chemical?
Well, it's making a graph of the chemical.
Yeah, this is the 2D, which is very graph-like. And I'm on the fence.
I don't think it makes a graph.
Right. I mean, it just makes
makes a picture that might have some similarity with a graph. It does not make a graph in any reasonable sense.
Okay, fair enough. Well, then this is basically some kind of layout method. Is that true?
Right, but I like it. I just chose structure diagram layout because it makes it clear that it's the 2D and it's not anything to do with
Okay, fine. I don't think that's objectionable. I think it should be a method sub-option. Fair?
Yeah.
And then a performance goal to be a higher level switching of that.
And so this next option, molecule embedding, I am imagining should have its name changed because it's a method. It's an option to give method options for generating the coordinates for 3D. It's the 3D analog of structure diagram layout.
Okay, so why don't we put it in the method option, and why don't we say, I mean, why not say, if we're going to do that, maybe it's wrong, layout 2D, layout 3D.
I think that would work.
Yeah.
Or should we say layout 2D options, if it's going to be a list of options there, like random seeding arrow, whatever. You know, which is it? Is it the case that what we really have is layout 2D method, and as well as, or layout 3D method, as well as potentially layout 3D options, which might be separate?
That's definitely true. So we have a few named methods for generating coordinates, and within those methods, we have a lot of sub options that are options for the library.
But remember that there's a sub option, so it sounds very much more similar to how we layer the methods in ND-solve and these other.
Yeah, I know. It's like this, which is typically like that.
Yeah.
All right. Okay. Fine. So I mean, if you don't object to layout 2D and layout 3D, is that reasonable?
Yeah, I think so. I can make that work.
Okay. Okay, so that's molecule embedding, alternate input forms. Oh my gosh. Okay. So you're saying I can put in this weird thing. Is that right? Are you saying I can put that in?
And it will parse it to it. Yeah.
And I assume that we're supporting that in interpreter as well.
That is the plan. I mean, right now I have it set up as its own function, name to smiles, but
I don't think it should be there. I mean, I think it should be an interpreter. Wow, that's pretty neat. So if I say here something like, if I just give a string like benzene or something, it'll just work. Okay, what happens if I like do benzene with a capital B? It'll just work. What happens if I do, what's the most complicated molecule? I mean, something where it has a name like caffeine that isn't an IUPAC name.
So it knows the Opsin parser knows a lot of different styles of nomenclature. It's
okay.
really,
so how does it relate to the parser that we're using for chemicals right now? Or are we using this one now?
we're using that in alpha right now.
Okay, fine.
If you scroll over in the other notebook, I include an example of a really long name that Opsin is able to parse into a chemical graph.
This thing here.
Yeah.
Okay, so if I say, so what you're telling me is if I say molecule of that creature, whatever that creature is, and then I try and, tempt fate and I say molecule plot 3D of that.
Right, that might fail or it might take forever, but it is abortable.
Okay.
It took a lot of work to make that abortable.
Okay, so why does it say unable to generate 3D coordinates for molecule?
So the random coordinate generation failed in that case. It didn't. So it created it created the bounds distance matrix and tried to generate random coordinates that satisfied it, and it did not succeed.
Okay, so what you're saying is that it couldn't find a configuration for that molecule that made sense.
Right. I've actually had some pretty decent experience.
By the way, I think this is too small. This thing, the other ones were too big. This is too small. It might as well go as far as it can to be visible. What do you do with that with graphs, Charles, in terms of sizing up like that when the graph is very detailed? Charles?
Sorry, I was on mute. Well, I don't remember top of my head, but we essentially use, we rely on the fact that we have the coordinate and not just the size.
Well, but if I ask for a K-ary tree with 1,000 elements, for example, right? A big messy thing. Okay, so why does that not? I mean, I guess that's a reasonable size for that graph, but you're not going wider than that for the graph, right? Whereas here, I do think it will be worth. Well, I don't know. You can always make it bigger. I guess you can always make it bigger. Roger, do you have a thought about this?
I think we shouldn't make that super sophisticated now, and now we can return to it.
All right, okay, fine. All right, this message, unable to generate 3D coordinates.
So that should be improved. I mean, I can tell the user that they can call embed molecule and give it a max iterations of an extremely high number and then just go for coffee or something like that.
And you can generate some entity for the caffeine molecule or something. Never mind. I'm just joking. What do you seriously want to say there? So what is the point? You can say, what you're really saying is
the distance geometry embedding failed or
it timed out. It didn't fail. It timed out.
Right.
Is that true?
It reached the number. I set an internal number of max iterations in it, and it reached it.
So,
attempts to embed.
What's that?
It's really attempts to embed successfully. Trying it, 10 times or whatever, and it didn't succeed on any of them.
Right. Unable to find a consistent, is that a fair statement? 3D structure after iterations.
Or attempts. I mean, it's not really iterating.
Okay, what's the option that allows you to do it for more attempts?
So it's a method option in the. So right now it would be molecule embedding goes to list, max iterations goes to this.
Okay, are we going to call it iterations or are we going to call it max? What do we call it when it's just a sample, like in Monte Carlo or in where it isn't an iteration? Because it's not an iteration. The point you're making, Bob, is that it's not an iteration. It just tries again.
Correct.
Okay, so what do we call that in other places where it's just trying again?
I'm trying to think of something where we do that.
What about Monte Carlo? What about max? What do we have that's max something like that? Max steps sounds like an iteration again.
Yeah.
Well, this is a string thing anyway.
What about max random seeds or something like that? Because that's kind of what it's doing.
Yeah. I think we should just call it, it's a string. I think we just call it max attempts.
Does anything have a restart capability in the language? Maximum, max restarts or something like that?
I don't think so.
Okay.
No, there is an example of that. Yes, something like ping time has a maximum. Oh, great, not set up here. Something like ping time, or there's a max retry type thing for. Let me think. Well, let's try ping time here.
Yeah, but max retries is very much what this is doing.
No, I understand that.
Yeah.
Time constraint. Where does that happen? That happens inside some kind of URL read functionality and things. I don't know. There is if you send it out to the core design mailing list, somebody will know. We have this thing where there's a retry effort. Something that does retries. I'm not sure. Max tries. Trials. I don't know. Tries, attempts. Attempts sounds like it's sort of pathetic and can't manage it. But I think there's a message like this is a better message here. Makes sense? And we could try and add some thing to say how to get it to do more attempts.
Does it have anything to do with continuous task?
I don't know.
I mean, I just plugged retry into the search for the documentation, and restart interval came up for continuous task.
No. It's not for tasks. It's for pinging servers. It's when you ping a server and there's a question how many times you retry for the server. Maybe somebody on the live stream knows. Okay, anyway, we can find a word for this. Okay. So, by the way, a question on the live stream. Can we compute the symmetry group of a molecule? I think the answer for right now is no.
No, the answer is yes.
Oh, well, that's more exciting. Okay, how do we do it?
I have to rehook it up because the molecule structure changed from the last time I implemented it.
And what does it return? Does it return one of our group objects?
Actually, no. We have to sort that out still. It returns the Schoenflies notation that chemists use, which is very similar to the Schoenflies notation used in the finite group data collection, but there are some disconnects that we have to sort out.
How bad are the disconnects, so to speak?
It's been a couple of weeks since I got that email, so I not too bad.
What is it? Is it finite group data?
Yes, finite group data. The thing is, the Schoenflies notation is only used for the crystallographic point groups, and there's a finite number of them.
Yes.
For molecules, though, they're not restricted to the crystallographic point groups. You could have, for example, something with C5H symmetry or C12H or something like that.
I understand, but it doesn't have to be. It doesn't have translation invariance, so it has. I mean, is that the point that it's?
No, not translation, but that the rotation axis is embeddable in 3-space or not, or in a crystallographic lattice, and 5-fold, 7-fold, 12-fold rotations are.
No, I understand. That's because they have to be a translation invariant crystal.
Yeah, that's right. Yeah.
Whereas it's just a free floating molecule. Okay.
Yes.
But here we've got crystallographic groups, crystallographic point group. Yeah, well, so fair enough. So we just don't have the notation for a molecular group, so to speak, molecular symmetry group.
Yes. If we added that, then I think we could resolve all the issues.
Well, why don't we do that? Because, I mean, that's, what will we call it? Molecular point group or something? Molecular symmetry group?
Yes, and then that also offers the opportunity to get to non-rigid symmetry groups, which have played a role in some aspects of chemistry.
Okay.
That's what I was doing with my postdoc.
Fair enough. That would be an issue for Jose, who did the finite group data thing.
Right. I talked with Jose. He's interested in getting somebody like an intern to curate the rest of the groups that we would need. We actually do have something hooked up in the system right now. If it's not pretty though. If you did symmetry information of molecule of benzene. I don't have any plans to move this one to the system context, but it's a molecule of benzene and then symmetry information with a capital S, capital I. No, so it's a function.
Oh, okay. Wow.
Right.
That's cool. D6H.
And then it shows so this all comes actually from a library. So we're trying to implement that in Wolfram Language, so we don't need to use the library. But this shows, so it gives the rotation elements, the planes of symmetry.
These are the actual elements of the group.
Right. So the C2 axes, it should have infinite planes for the symmetry planes, which there will be a lot of them for this guy.
That's the sigmas or something.
That's a mirror reflection.
An S6 is a symmetric group on 6 elements.
No, that's an alternating reflection rotation.
Or an improper rotation is
an improper rotation. You rotate a certain amount and then reflect through a plane orthogonal to the axis.
Okay. All right. So let's keep going here. So this is ways to get. So you're hooking this up to interpreter. You can go from a smile string.
I'm going to have to leave, fortunately.
Yeah. Let's just check whether there's anything else for you particularly here, Roger. I guess not, so long as Charles can stay. Okay. Thanks, Roger. Okay, so what are we talking about here? So what is this? What is that smiles list? What are you doing here?
If you wanted 10,000 random smile strings to play around with, that would be one that you could use random choice on.
Okay.
I find those to be helpful when I'm testing these things out.
Yes. Okay. Where did you get the random smile strings? I mean, you generated the random smile strings?
No, from a resource object that so from the Pitt Quantum Repository, some researchers at the University of Pittsburgh took about 100,000 different molecules and did quantum chemistry calculations on them, and they made it publicly available. So it's a resource object.
Do we have it in the data repository?
Yeah.
Neat. Okay. It's very cool. By the way, that is ugly. I mean, in terms of just the visual appearance, again, you got to do something with that sizing.
Agreed.
So again, some heuristics there. Don't ever make the fonts bigger than a certain size. I can't make that smaller, I guess, at all. And in terms of this, when it gets long, wait a minute, let's do this crazy one here. Let's look at what that thing looks like. So you're saying, I see. So if you say this, okay. Oh. And it's wrapping somewhere there, right?
Right.
I mean, it doesn't have a hell of a lot of choice here. I think this is acceptable, what it's doing.
I mean, the other option would be for me
This element is wider. What is the wrapping width here?
Whatever the default is for the summary box, I don't have anything set there.
But there's something that's gone wrong because the summary box is wider than the screen. Also, for goodness sake, I've already said this 5 times.
The colon. Yeah.
Okay, but so this bizarrely is, it seems to be a summary box which doesn't know how wide the screen is. So why don't you ask the summary box experts what the deal is with that?
Yeah.
I have never seen them taking this into account.
I mean, I could
look,
check.
Michael, if you hit the edge of the summary box, why isn't it? I don't understand why the thing isn't. Well, I don't know what it's doing. It doesn't. I don't consider this terribly important. I think this is definitely a weird corner case.
It's making the choice to do some kind of wrapping, but why is the
why is the wrapping width the wrapping width? What is this?
For convenience, that's how I make a molecule out of like an entity. Is I grab all the rules, and I mean I don't have to advertise that as a method to create a molecule, but that will work.
Okay. Okay, that's cool. That's very cool. So, are you saying if I say, how do I make? So let's say I say a Carey tree. And how do I specify that it is, okay, well, hold on, I'm about to find out this. Okay, so if I say Carey tree of 40 or something, fine. Now I say, but those are not carbon atoms necessarily because they're trivalent, right, in this picture.
Right, and so it might just say that those are nitrogens. I think I made it very stupid.
Weird. That is officially weird. Okay, so if I now say, I mean, it's cool, but...
yeah, could you do a molecule plot, please?
Yeah. That's distinctly weird. What the heck did that do there?
So the layout algorithm wasn't able to lay them out sufficiently? Or
well, what do you mean by sufficient? I mean, that nitrogen has a ridiculous valence there, doesn't it?
No, I think that it's placing two nitrogens right on top of each other, I think.
Yeah, those have to be from not quite
that's not a complete ring, that middle one.
Well, let's look at it.
Yes, yeah.
Actually, there are no rings. Okay.
Well, no, it can't be a ring. It's a tree.
Right. Okay.
Yeah.
That makes a lot of sense.
Okay, well, that's quite beautiful, except I'm confused by its weird and random. I mean, is that a sensible thing to do, to just assume it's a nitrogen if it's, I guess you might as well. But couldn't it also be a carbon with a bunch of extra hydrogens hanging off?
It could be that, and maybe some options could let one do that, control that capability.
Right. I mean, yeah, I didn't quite know what to do there. I mean, we could have...
What is the more plausible thing? Seriously, if one was building, I thought, back in the day, people were building molecules like dogosine and so on, right? And they were made of carbons. I mean, before buckyballs were known.
Yeah, I would expect the default atom to be carbon.
So, okay, so but then you would be okay with it adding hydrogens. Is that?
Yeah.
Okay.
Yeah. I would.
Okay, so let's take the first of these. How do I get the actual graph for this? Can I just say graph of that entity, Charles? You should be able to.
Well, in prototype build, I think we did that, unless I forgot to build it.
This is the prototype build. This is the product I built, so something's gone wrong there. So you should check that. But how do I get the graph out of this?
I mean, it should have a graph property, I would think, but...
Okay, so if I now say, that's pretty neat. I mean, if I can say molecule...
Man, I'm really hoping it doesn't give a horrible message.
Molecule could not find number of expected rings.
Right, that's a message I need to figure out what the library is saying. So in that case, I'm just giving the library message, and I shouldn't do that. I know, I'll remove that and silence them.
But what does it mean? I mean, what are you going to say in that case? Could not generate a molecule from this thing, but why couldn't you generate a molecule? It looks like it has, everything's quadrivalent. Seems beautiful to me.
Right. I think it's going to be. I think I need to hunt down what the bug is, and then I'm going to find there's a bug in the library we're calling.
Okay.
Yeah, I think it's because you've got so many cycles there. Its ring finding algorithm is failing. And it needs to find the ring so it knows how to apply special rules for the distance geometry.
So if I say molecule plot %60, you think it's also going to fail there? Yep. Okay. So now if I do this one.
That should give you dodecahedron, I think.
Oops. %62. What the heck is that?
Nitrogens. Those are nitrogens in there.
So my heuristic for determining the font size is really suboptimal.
That's a bunch of giant N's.
Yes.
Yeah.
Okay. So why are you changing the font size of these things? Why are you not? I mean, when the font size needs to have a maximum, right? And it should never be above the maximum.
Right. So in the end, I'm calling font size scaled.
But that's wrong. That's wrong. You should ask John Fultz or Lou or somebody how to deal with that. They have some way of dealing with font sizes that can be, scale up to a certain size. Now, why does it say that? That's because it didn't iterate. It could not find them with the right number of iterations. Is that right?
Right.
Okay, well, we're not doing fantastically here. Let's see what happens if we try this fullerene graph. Is that the one I just tried?
Yes.
What is this thing here? Non-transitive Cayley graph. I mean, I'm avoiding trying a random graph because I think its likelihood of working is very low, given what we're seeing here. Oh, boy. There's no way that's going to work.
Right.
No, not even with uranium.
Okay, well, so we need better. So what are we going to do if the valence is above 4? Are we going to generate a message? Or what are we going to do? Are we going to randomly pick? What's the highest valence atom in the periodic table?
Generally 6, maybe 8. And those are really bizarre molecules.
What element has valence 6?
Sulfur, for example, can have up to 6.
So it's another shell. It uses another shell for that.
Right. I mean, haven't they been able to just throw tons and tons of things on like xenon recently?
Well, xenon hexafluoride is the traditional one that I know of from way back. But
okay, what are we going to do if the valence is above 4? Give an error message? It's rather unhelpful.
So I think I could give a better error message. So in this case, I apparently just made it carbon, even though it had a valence of 9.
Okay, why don't we do this? In the method option for molecule, right? Couldn't we have something which says something like I don't know. I'm atom types arrow, and then given a valence, what the atom type is supposed to be.
We could do that.
And that would be just specifically for this case of interpreting.
Yeah, right, of interpreting a graph.
So graph valence rules? Something that made it...
Yeah, that makes sense. That's a good idea.
Yeah. Now, what about multigraphs? And would, 2 edges represent a double bond, 3 edges a triple bond?
Right. That would certainly be a more sophisticated, a better way of doing it than what I'm doing here. I mean, and also one could assume that the users might have filled out the properties of their vertices. So right now, if you create a molecule and get a graph from it, I will populate the properties of that graph.
Yeah. But there are not standard properties, though, are there, Jason?
Right. No, they would be string values. So, but graph supports non-standard.
Oh, I know it does. Yes.
Okay, this is getting too ornate. I think for this version, why don't we put in a graph valence rules, and why don't we have the default value be 1 or 2 or 3 or 4 arrow C?
Mm-hmm.
And leave it at that. And if you want to put in something exotic for higher ones, I suppose you could, but I don't think that's going to be useful.
Right. So, or 1 goes to H, and then everything else goes to C, or 2, 3.
Oh, do you want 1 goes to H?
No, I think they should all go to, by default, all go to carbon, because that's what you would expect.
So I guess I was thinking that with that the example in the other one, the graph data of octane, that should produce octane. And so right now, that's basically all that what I wrote does.
What other graph data things are there that are molecule-like? Is there a fullerene? Yeah, there is. Oh gosh, this is huge. This is absolutely huge. Oh, not so huge. But yet we couldn't do this, could we? We just tried this and it didn't work.
We couldn't generate a nice picture of it.
And even in 2D.
Right, because of my...
No, because of your end craziness. But
it might be able to do that. It can't do C60.
So your argument is, I'm sorry, go ahead. Your argument is we have...
well, I was about to say no, I don't really have it.
Okay, I do agree that graph data of octane better actually, if you say molecule of graph data of octane, it really should generate that. I mean, okay, fair enough. I mean, we could have the default be 1 arrow hydrogen, 2, 3, 4 arrow carbon. Bob, do you think that's horrifying?
No, we could do that. And those that wanted strictly, all carbons could easily override that.
Fair enough. Okay, shall I just send you this, Jason?
The one thing that I think still is outstanding is what you do with a valence greater than 4 in your graph.
I think you punt for now.
Jason, is there any kind of, generic atom that would, or do we just have too many bonds?
Right. So actually, we have defined valence states for a handful of atoms. And if you try and make a 5-valent carbon, we will say that doesn't work. But for vast swaths of the periodic table, we've got no established valence rules. So I imagine if you just made them iron, it would make a horrible molecule, but it would pass the valence checks.
We could make them tungsten just for fun.
Right.
No,
right.
I'm slightly joking, but what is the right generic atom? If there is a generic atom, what would it be?
Well, in Wolfram language, it has to be tungsten.
I think it's really random to do that. I mean, it's amusing. It's kind of a joke.
Well, before the transuranium elements had names, recently they named them up to like 120 or something, but they had these, Undec, some Latin or Greek name that.
Right, Unanoctium was one of them.
Yeah, is there some kind of generic name that we could use for just plain, ultravalent, hypervalent, or something like that we could use for this case, Jason?
Let's see. I'll look into that. I'm taking notes here, so I'll make a one about high valent.
I mean, but now we certainly could have the joke of having it be tungsten. Or we could have it fail. Either way is fine.
This, I think, is going to... I don't know that this will be quite ready for...
so we can do proteins?
But they're...
Oh, that's RNA.
Right. So we can't fold them. If you could make that sequence, it would be very easy to make a sequence that's too big to plot realistically.
Okay, but for RNA, can we do it?
Yeah. So I've even set up the autocomplete with this one. So you would do sequence, molecule, enter a sequence, and then it gives like 8 different options of the types that are supported, like so RNA, wow. DNA, or amino acid sequence.
Okay.
In general, in the future, I think we want to do
to be in there.
Okay.
Yeah. Okay. What were you going to say?
Just that dealing with macromolecules is something that we definitely want to do correctly after we establish the molecule. So in general, a protein or a macromolecule, you wouldn't want to have every atom be explicit in the list of vertices. You would want to do some kind of coarse graining.
Yeah, right. We talked about this before.
Yeah. And so the molecule isn't the right container for that in the end. But you can make a molecule with,
We're working on a proposal, so have something else.
Yeah. And there's some special layout rules for 2D rendering as well for the different kinds. RNA is a classic one where there's, a special way of handling that with the cross linkages.
What the heck is this? Oh my gosh, this is complicated.
So this takes us into talking about patterns. We can have atom patterns, whole substructure patterns, or bond patterns.
Boy, at the end of this, we're actually going to be able to do. I mean, this is a pretty nice way of understanding chemistry. Maybe I'll even understand something about chemistry after all these years. Okay. What does total connections mean? That means total bonds, or what does that mean?
Right.
Why isn't it called total bonds?
I kind of based those names off of the smarts, this kind of regex for molecules, and so in they tend to call it the number of connections, but there's no reason that it would need to be. I mean, it's like the vertex degree, right?
But isn't that the bond number, the number of bonds?
Yes. As opposed to like the valence or something that counts the order of the bonds. That's just the total. Yeah. Total connections is the total number of bonds.
So why not call it total bonds? I mean, if there's a double bond, it counts for 2, yes?
Well, no. So not in this. So the double bond would count for 2 in like the valence.
Oh, I see. So I could equally well here say atom, valence, arrow, blah. Is that right?
Yeah.
I see.
And these are things that you can put in that aren't so those are just for queries, right? So an atom with total connections goes to 1 inside a molecule would make no sense, but it makes sense as a pattern. Which is why I have the pattern molecule head. But I don't know that we'll get to that today.
I don't see the pattern molecule head here.
It is not in that list.
Okay. Molecule Q.
Right.
Why isn't that just telling what the head of the thing is? Why do we need a molecule Q? Is it to check whether it's a valid molecule?
Right.
It doesn't check. I mean, if we had xenon pentafluoride, would it tell us it wasn't a valid molecule or not?
I don't think it would reject that. I mean, it checks the molecule against the rules that we have set up. If it comes back as molecule Q, then I can do lots of other things with it.
I mean, because it doesn't make something atomic, we need something like this.
Fair enough. That's not a beautiful message.
Right.
Okay. We already looked at this. Yeah, just find out how to do this from the front end team. But it's really quite beautiful what it's doing here. So now this highlighting business, why does it have double braces here?
Let's see, it doesn't need to in that case. You could have 1, 2, 3, comma 4, 5, 6, and it would highlight 1, 2, 3 in a different color than 4, 5, 6.
Very nice. Okay, so I can play. That's magnificent. So is there a plot style option here that determines those colors?
No. So how...
And why did molecule plot suddenly go black for everything else?
Okay, so yeah, so any atom that has a disk behind it, I make white in order to be able to see it, and so that was what. So if I'm making them white, I
it's not a good idea. You should not change the colors of the rest of the molecule just because you're highlighting something.
Okay.
I mean, this is a question for the design group, what we should do here. And I also don't agree with just ask the design group what to do. I suspect what we should do is put some opacity on top of this, right? And leave the color, leave the oxygen to be red.
Mm-hmm.
Get what I'm saying?
Mm-hmm.
And put the disk with some opacity. I think that will work fine.
Yeah, I agree. That would be good. For graphs, Jason, when you highlight different parts, you can wrap an atom or an edge or a subgraph with a style. So you would say style and then list your atoms and then comma, red or blue or whatever. So maybe we could do something like that here.
Well, so with graph, I mean, you don't need graph plot because you're putting all that information inside the graph. Here, I mean, let's see.
Look,
so we could have
so
style.
one thing we could do is to model this after list plot. Okay, so if I say list plot, 1, 2, 3, right, and then I could say style of 1, comma red.
Mm-hmm.
Okay, and I could say 2 is as a call out. Right, you should be able to use the exact same code.
So in the second argument molecule plot where you're specifying the things that you're highlighting, that's where you would wrap. So it would be style list 1,
Exactly.
2, 3. Okay.
Yeah. Or whatever it is, or style. I mean, that way you can determine how you're highlighting them, and the default should be some opacity type thing.
Mm-hmm.
Ask Jeremy or somebody in the design group for this.
Mm-hmm.
Okay, you can make it look really good. What on earth is this? Contains structure Q.
Something I forgot to take out of this notebook, I believe.
So we're not ready for that yet.
Right.
Molecule substructure Q or something.
Right.
Submolecule Q, so to speak.
So I think molecule position might be the best one to go to next, or go along the list here.
That's magnificent. Oh, what's that? Highlights. Okay, what do you mean by highlights here? What is the difference between highlights and the thing you were showing before for molecule plot? Why is that not a second argument to molecule plot 3D, just like it's a second argument to molecule plot?
So I reused an older notebook. It is the current syntax is for it to be a second argument.
Okay, great. So if I now do this Buckminster-Fullerene thing, so this is something where it's successfully doing. Okay.
So it's just grabbing the coordinates from the knowledge base, so it doesn't even have to.
Have to do what?
It doesn't have to generate. That's why it has such a nice 2D.
Okay, so here I just say smarts pattern. I don't know what a smarts pattern is. Why am I saying smarts pattern? Can I just give the string?
No, so in this case, it needs that to know that what type of string it is.
So that's going to be another complicated story. What did it do wrong? Is that plot theme working?
No, let's see. I'm not entirely certain why that's broken at the moment.
Okay.
But so that smarts pattern, it's like a regex for molecule substructures.
Yeah, I know.
And I have a Wolfram Language version of that smarts pattern.
What is a purple atom?
Right.
Is it phosphorus?
Is
that phosphorus or something? What is a purple atom?
No. So what happened here is, again, like because I added highlights, I just made everything gray. Which
that's
here I think here it might be better to have a sphere that's slightly larger than the normal.
I agree. A sphere. What I would do to highlight these is have have a kind of a photo spin. Have a sphere around it, right? A translucent sphere around it.
Yeah, and a translucent tube around the bonds.
Yes, why not? Right. So it's just like it is literally a generalization. So in 2D, it becomes a disk, a translucent disk, and in 3D, it's a translucent sphere. This is lovely functionality, but we are deeply running out of time. We should probably go on at a different time here. Let's try to pick this up early next week. We've clearly got, what on earth is all this stuff? Oh my gosh!
Right,
all this stuff.
These are
okay. Those are operations. Okay, well, fair enough. We don't have similar things for graphs, do we? For graphs, we just have a limited number of functions to change them.
Yeah, delete edge, delete bond, add edge, add bond.
Okay, I'm just curious here.
Right, so this would be for making a molecule nearest function. They use these fingerprints that look like that.
What do we have in terms of a net encoder for neural nets for molecules? Do we have an obvious way to do that?
So let's see. I've been looking at this past summer at a few different like preprocessors for neural nets. One of them, which is to make a vector, or to make. So we've been coming up with a couple this past summer with an intern and so we're going to have a few nets to put on the repository to deal with this.
You mean things like node-to-vec sort of things for molecules?
Right. So I don't know what that is, but I mean a couple of things that will take a molecule.
Word-to-vec. You mean something like word-to-vec for a molecule? Is that what you meant, Bob?
No, I meant node-to-vec. That's out of Stanford also.
Okay.
For taking a graph and turning it into some kind of vector representation for neural nets.
Right. So we've experimented with a few different of those, and so we have one neural net that takes a molecule and creates an image out of it, like a 2D structure, one of these 2D structure diagrams, but then encodes chemical information in the channels of the image. Then we have another method that uses the 3D structure to generate the input vector. Those are the two that we've experimented with.
Okay. Hey, let me ask you about the status of this chemical drawing thing. So you have a JavaScript application that is doing this, is that right?
Right, but it's
still clunky. There's some issues. It only draws de novo. It won't take a molecule to start from is one thing.
Bad. Yeah.
Also, if you can end up making mistakes and have an atom hiding behind another atom or a bond hiding behind another bond, and you don't know it until you try to import it, until you bring it back in, and then it's not a real molecule and you're getting error messages. Those should be highlighted in the drawing tool itself so you can correct them.
Right. So for that, we need the drawing tool to actually communicate with the Wolfram kernel, and then also there's the fact that the container, like the shippable container that we have for this right now, since we don't want it to use your web browser, it's using JS.
Node.js.
Right. No, it's but there's a special like quasi browser that comes with that makes this thing. The Packlet that we have, the version that we are working with right now, is several hundred megabytes because of that. So that's something we need to fix also.
Okay, but doesn't external evaluate allow you to evaluate JavaScript code using a Node.js server?
Right, but I don't know how to use it.
Okay, well, so you
Let's
could
do
ask
this.
Garrett.
Let's first get this out what we have.
Fine. Okay, well, there's a lot of magnificent stuff here. Great. Okay, so look, we clearly we're going to need another couple of hours, I think, to go through this. So we should get that scheduled and take it from there.
Okay. Yeah.
All right. Thanks to everybody. Wait a minute. Let me just look at these questions on this live stream. How did it find a 2D embedding but not 3D? Because the 2D embedding is just a diagram. 3D requires actual realistic atomic positions. Michael Hale, from graph to molecule, perhaps a vertex property can also determine the atom type. Yes, indeed. From a vertex property in the graph. Yes, I agree. Okay. Well, thanks, everybody. To be continued in a few days. All right. See you later.
Have a nice weekend.
Likewise. Bye.